Okay, so what I have done is I have created some more space here. So let us solve this question now. This is the nth term that is given. So sum of n terms will be equal to sigma k equal to 1 to n k squared plus 2 raised to power k. This is something that we have discussed ample number of times. I hope you understand that. So we can write this separately as k equal to 1 to n k squared plus k equal to 1 to n 2 raised to power k. This is simply the sum of squares of first n natural numbers. So n into n plus 1, 2n plus 1 upon 6. The second term here is simply a GP because it is what? 2 raised to power 1 plus 2 raised to power 2 plus 2 raised to power 3 up to 2 raised to power n. So this is a GP with first term as 2 and common ratio as 2. So what is this sum of GP where first term is first term is 2. So 2 r raised to power n minus 1 r minus 1. So this is the answer, n plus 1 2n plus 1 upon 6, and this is 1, right? So I can write it as 2 raised to power n plus 1 minus 2, or you can leave it like this also, 2 into 2 raised to power n minus 1. Alright, I hope you got this question. This was a pretty simple question. I just did it in a different lecture because just to create some more space. Alright, let's move on to the next question, which is the last question of this exercise. After that we will start the miscellaneous exercise. So what is this? This is nth term, right? So what will be the kth term, or let us write the nth term in an expanded form first. 4n squared plus 1 minus 4n, right? So I can say kth term will be 4k squared minus 4k plus 1. Now I will write Sn. It is sigma of this, right? K goes from 1 to n. So let me write the separate terms. 4 into sigma k equal to 1 to n k squared minus 4 into sigma k equal to 1 to n k plus sigma k equal to 1 to n, and this is simply 1. Alright, this is 4 into n plus 1 2n plus 1 by 6 minus 4 into n plus 1 by 2, and this is 1 plus 1 plus 1 n times, so I'll write n. Now just the simplification part is left. So how do I simplify it further? I can take n common from everywhere, and let me cancel this. This will become 2, this will become 2, and this will be 3. So I am taking n outside. From the first term I have taken this outside. N plus 1 into 2n plus 1 will give me, and there is this 2 which is being multiplied here. If I, okay, let me do it separately. So 2 into 2n squared plus 3n plus 1 will come here, and in the denominator I have 3. Then minus, this we can do, n I have taken outside, right? So we can simply write it as minus 2n minus 2, okay, plus, and this is gone outside, so I'll have plus 1 here. Now final step of simplification will give me 4n squared plus 6n plus 2 minus 6n, right? Because LCM is 3, so I'll multiply these terms by 3. So minus 6n minus 6 plus 3 and whole divided by 3. So this is equal to n into, this is 4n squared 6n into, so this 6n, this 6n, these got cancelled. 2 plus 3 5 minus 6, so minus 1, and divided by 3. This factorization is very simple. This is a squared minus b squared form, So I can write it as a plus b, that is 2n plus 1, a minus b, that is 2n minus 1, and this thing divided by 3 is my final answer. I hope you have understood this exercise. After this, we will start our miscellaneous exercise. Thank you.